I'll cover the concurrency section of the 12-factor app. Let's get started. The first thing to talk about is a scale out via the process model. Let's see what that is about. So any computer program, once run, is represented by one or more processes. So any program, basically, it's a process, nothing more than that. Web apps have taken a variety of process execution forms. So web apps can take in a variety of process execution forms. We'll see what that is about. For example, PHP processes run as child processes of Apache. Okay, so PHP process is nothing but a child process of Apache, started on demand as needed by the request volume. So we can start multiple PHP processes. Java processes take the opposite approach, with JVM providing one massive Uber process that reserves a large block of system resources on startup. So Java processes take the opposite approach of PHP, where where the JVM provides one massive Uber process that reserves a large block of system resources, with concurrency managed internally via threads. Okay, so concurrency is managed internally via threads. In both cases, the running process or processes are only minimally visible to the developers of the app. They are very minimally visible to the developers of the app. In the 12-factor app, processes are a first-class citizen. So in 12-factor app, processes are first-class citizens. We'll know what that means in the next few paragraphs. Processes in the 12-factor app take strong cues from the Unix process model for running service daemons. So processes in a 12-factor app are modeled after the Unix process model, is what I'm getting from that. So using this model, the developer can architect their app to handle diverse workloads by assigning each type of work to a process type. Okay. So using this process, the developer can architect their app to handle diverse workload by assigning each type of work to a process type. Okay, that's what this example shows, I think. So the web 1, web 2 are the processes that handle the web traffic, and there are a bunch of workers that do the work, and there is a clock that I'm guessing that's used for scheduling. Anyway, we'll see. For example, HTTP requests may be handled by web process. Yeah, that's what we just talked about. This web 1 and web 2 are HTTP processes. And the long-running background tasks are handled by worker processes. Okay, so anything that's long-running is handled by these worker processes. This does not exclude individual processes from handling their own internal multiplexing via threads inside the runtime VM. So even though we have these processes, they're saying this doesn't exclude a process from handling their internal multiplexing via threads. So they can have multiple threads. Each worker can have multiple threads, is what this means. Or the async evented model found in tools such as Event Machine, Twisted, or Node.js. Okay. So processes can use async and evented model in tools like Node.js. I'm familiar with Node.js. I'm not familiar with Event Machine or Twisted. But an individual VM can only grow so large. So individual VM can only grow so large. So basically, if there is only, let's say, 16 gig of memory, the virtual memory, 16 gig of memory available, the VM can only use up to 16 gig. So it can only scale vertically up to a certain extent. So the application must be able to span multiple processes running on multiple physical machines. So they're saying the application must be able to span multiple processes, physical machines. So if you want to scale it on multiple machines, if only 16 gig is allocated to, say, let's say a virtual machine, then either you have to span off multiple processes, so each process can avail of the memory that's available, or you might want to run your app on other physical machine also, basically scale horizontally. The process model truly shines when it comes time to scale. This process model will scale when it comes time to scale. The share nothing horizontal partitionable nature of 12-factor app processes means that adding more concurrency is as simple and reliable operation, because we don't share anything, and it's stateless. You can scale a 12-factor app, can easily scale without a lot of changes, and it can scale reliably also. So we can have concurrent processes, concurrent apps running, and the processes inside of the app also can be run concurrently. The array of process types and number of processes of each type is known as process information. So if you see in the array of process types and number of processes of each type, if you see Web 1 and Web 2 are HTTP processes, and worker processes, these are worker 1 to 4 is another array of worker processes. Clock, I'm guessing, is a scheduler process. So this is called process information. Basically, process information consists of array of process types and the processes themselves. 12-factor app processes should never demonize or write PID files. Instead, rely on operating system's process manager, such as Upstart, a distributed process manager on a cloud platform, or a tool like Foreman in development, to manage output streams, respond to crashed processes, and handle user-initiated restarts and shutdowns. So they're saying 12-factor apps should never demonize. So you cannot run it as a daemon or write PID files. So instead, they should rely on operating systems process manager to manage output streams and respond to crashed processes. So use a tool like Upstart to orchestrate the processes. Upstart is an event-based replacement for init daemon. So it looks like Upstart is an orchestrator for processes. They're saying use something like this or Foreman in development to manage output streams. So if there is a crash, Upstart should be able to figure out how to restart it. Or if we need to shut it down, how to shut it down gracefully. So to summarize concurrency, in a 12-factor app, processes are first-class citizens. So they're modeled after the Unix process model. So processes, because processes don't share state, they can be scaled horizontally with very little effort. So scaling is pretty easy. And a 12-factor app should never be demonized. We should use operating system process manager like upstart to orchestrate the processes. At a high level, that's the summary of concurrency. So to achieve concurrency, that means scaling horizontally to achieve concurrency. Everything in a two-factor process, a two-factor app is a process. So that's, and then share state is not shared. So we can achieve concurrency by scaling horizontally with very little effort. That's a summary of concurrency. So let me go to the next one. So disposability, I will talk about disposability in the next video.